Okay, so you know how when we were little, we've actually learned more and more. We expand our knowledge on certain things. I'm gonna ask you this. If I say, okay, this is before we talk about powers and exponents. What is that equal to?
How about page 16? The word. What is called page 16?
Okay, hold on for a second. What would this equal to? 12. Okay. Is there a shortcut for this?
Yes. Yeah.
Yeah.
4 times 3.
Okay, the shortcut would be
4 times 3.
4 times 3. And that will give us a 12, right? Okay, good. Now, if I go like this, four times 4 times 4. Okay, go ahead and put that onto your calculator. 4 times 4 times 4. $64. What's the shortcut for this?
16 times 4.
The shortcut for this would be 4 to the power 3. Okay, go ahead and put that onto your calculator. 4 to the exponent 3. Did you get 64? Yeah. So as you can see that repeated addition could be expressed as multiplication, but repeated multiplication, another way of writing that, instead of 4 times 4 times 4, we can write it down as using exponents.
Yes.
So exponents really is a repeated
Numbers.
multiplication. Yeah, multiplying of the same numbers over and over again. So when you have an exponent, that's what it really means. Nothing special. It is somewhat special. The special part of that is that we don't have to do the 4 times 4 times 4, right? The long way. So that leads to our exponents and powers. So our goal is to demonstrate understanding of power and exponent, and rewrite the factors as exponents. So exponent notation is used to represent multiplication. And then this is basically the repeated multiplication. Repeated multiplication. For example, 3 times 3 times 3 times 3. That's a long way, right? 3 times 3 times 3 times 3. You're going to get the right answer, 81, but that's a long way. Well, what's another shortcut for that? 3 to what? To the exponent of 4. Well, what's the 4? The 4 means how many 3's do we have to multiply? Right? There are 4 3's. Right? There are 4 3's. So our exponent is the 4. Of course, yes, I am. Yeah. So we would read it as base 3 raised to the power of 4. The whole thing is called power. The whole thing is called the power, but the 3 is our base and the 4 is our exponent. So the base is the number that is repeatedly multiplied. And then the exponent, that, which is the 4, tells us how many times do we multiply. Okay? So 3 to the 4, or you can read this 3 to the power 4. We can read this as 5 to the power of 2, but another power of 2. A simple way of saying that is 5 squared. 7 to the power of 3. Another way of saying that is 7 cubed. 7 cubed. So looking at this, the main purpose of this is for us to get into understanding of what this exponent does. So when we have a standard multiplication, what would this be in exponential form or in a power form?
6 to the
6 is what we're repeatedly multiplying, and then the exponent tells us how many do we have to multiply. There's 5, so 6 to the power of 5. So 6
Exponent
to the power 5, or 6 to the exponent 5, correct. What would this be?
x squared.
8 to the 2. 8. Okay, so we can say that. How do we read that? 8 to the power of 2. What's another way of saying that? Or 8 squared, or exponent 2. Yeah. What's this one? 1 to the power of 8. Okay. 1 to the power of 8. And what would this be? Last one.
9 cubed.
9 cubed. 9 cubed, or to the power of 3. Now I'm going to ask you this. Okay, I'm going to look at this one. Is there a difference? Tell me if you agree with this. Are these the same thing? Can I mix them up?
Yeah.
Can I mix this 2 up? 3 squared, 2 cubed.
No.
No,
Different.
it's different, okay? No, it's not. Because when you look at 3 squared, it really means 3 times 3. We're going to have 3, and how many times do we multiply 3? 2 of them. 2.
6.
So 3 times 3 is
9.
9. Now, what about this one? 2 cubed. What would that be?
Oh, it's same.
2 times 2 times 2. So you're going to have a number 2, and how many times do you multiply the 2's?
3.
3 factors of 2. And what's this equal to? 2 times 2 is 4.
Yeah.
Times 2 is 8. So this one is 9. This one is 8. Right? How would this be? Write it in words. Yeah, I'll get you to fill this out on your own. Use your calculator, please, because this can get really, really big. So I'll give you a moment to do that. Writing it in words, and then your standard multiplication. Yeah. So, yeah, writing it out in words. So 11,
To the power
I'll give you an example. 11 cubed, or 11 to the power 3, something like that. Okay, it's all good? Okay, so what would this be? 11 cubed? Standard multiplication would be
11 times.
11 times 11 times 11. And then evaluated form would be 11 1,331. 6 squared would be, 6 squared. So that's 6 times 6. That's easy, 36. And then 9 to the power 4. 9 to power 4. Or exponent 4, right? And that's a huge number. You got 6,561. That's 9 times 9 times 9 times 9. Okay. So the reason for this exercise is for us to figure out the meaning, real meaning of the. Okay. There's an assignment question in here for you to do. So I'll get you to work on that one. Is everybody okay with that? The last one at the very bottom is a little bit weird and challenging, right?
Yeah.
Actually, in fact, there are two answers to that question.
Divided.
Would you like to share your solution? No? Okay. That's fine. Not yet. Not yet. Anybody figured out this one? Sure, no, go ahead. Oh, you're saying square root? Square root of 79? Right? Okay. What did you get?
Yeah.
It's 27. Okay. So the last one could be 27 times 27. Or you can go 27 squared, right? Anybody else have a different answer? 9 cubed?
Yeah.
9 cubed. So 9 to the exponent 3. I thought I got all of the answers. I don't have all. Okay, 9 cubed also works. Ernestine, you got a different one?
I did 3 to the power 6.
Okay, excellent. Yeah, so this one here, I'm going to write down all of those possibilities. 9 cubed. Oop, that's not how it is. So 9 cubed, which also 729. And then, what was yours? 3 to the exponent 6. The other possibility would be 3 to the power of 6. 1, 2, 3, 4, 5, 6, 7, 29. So there are actually 3 answers for that one. Is everybody okay with that? It's a lot of calculator stuff. How much time do we have? 10. Okay, we got about 15 more minutes. Would it be okay if we just jump right into the next one? Yeah? You're not going to be too... Okay. Jump to lesson 5. Now, if there is such thing as an operation in math, there's always the opposite operation, okay? And what I'm saying is this. We know that when we have addition, the opposite operation is subtraction. Everything has its opposite. Even integers have an opposite. So addition is opposite of subtraction. A multiplication, the opposite is division. Squaring, so squaring, the opposite of squaring is actually square root. Square root. Now, to reverse that, I think most of the calculators are very good with having the opposite operations side by side or close to each other. I'll give you an example here. My calculator here, plus and minus are opposites of each other. Multiply, divide are right beside each other. Oh, this one's not quite good. There's a squaring here, and then there's a square root there. Well, that's no good. Is there anybody here have a different calculator?
I do.
Okay. That one works. So,
This one I checked for the y, exponent to x.
oh, exponent would be this.
Oh, this
Yeah.
one, okay.
Here. Q square root, oh, this one, square and square root, right beside each other here, square and square root. So square and square root are opposites of each other. What about the cube? Would be cube root, cube root. So what does that mean? If we're squaring something, if we have 3 squared and we get 9, so this is squaring. The opposite of squaring is square root. So if we square root this, what do we get? The 3. 27 cubed. Oh, no. Got the answer. 3 cubed is 27. But then if you take the cube root of 27, what do you get? Is a 3. Okay? So, those are the roots. And the one that we're going to really particularly focus on are square roots and cube roots for this course. So the radical symbol, we know what that looks like, is used to represent the root of a number. The number placed under the radical sign is called the radicand. Okay, the radicand is a number inside. The most common radicand we solve are square root and cube root. So square root of 4 is 2. Cube root of 8 is 2. Now this one here is very, very simple. Determine the square root of the following. So go ahead and figure out the square root of 576. What did you get for this? Determine the square root. Is 24. Okay, can everybody find their square root button on their calculator?
I got 22.9.
Oh, 576? 24. You got 24. Let me take a look. Yeah. Yeah, 24. Oh, maybe, yeah. Okay, what's the next one? What's the square root of 324?
18.
18. Is it always going to be a nice number all the time?
No.
No. Right? Like these examples, the answer is 24 and 18, but not all answers are going to be nice like 24 and 18. Okay, take a square root of 50. What would the square root of 50 be? 7.07 and so on, right? So I just want to make sure that we understand that when we take the square root, it might not always be a nice whole number like that. Okay, let's take a look at example number 2. Determine the cube root. How do you do cube root on your calculator? Okay, some of you might have a cube root. Some of you might not. Now, look for something like this on your calculator. See if you have that. Some of you have a cube root button, so that's good. That's okay. Anybody has this button? You have both. Okay, that's okay. So if you find that button, if this is the button that you have, what you need to do to get to know your calculator here, you're gonna type in 3 and then this and then the 64. Okay, so give that a try and see what number you get. 4? Yeah, you get. Did everybody get 4? Okay, if not, then yeah, let's figure it out. Okay, now let's take the cube root of 1,000. Cube root of 1,000 is 10. Did we do cube root? Oh yeah, square. It's gonna be 10. Okay, is that nice? Is that good? Any questions there? You have a cube root or no? Oh, here, this one. So you go 3. That, and then 1,000. Okay, so you understand how your calculator works? Okay, good. That concludes our lesson for today. For your homework, you can finish off the lesson 5 assignment. Lesson 4 and lesson 5.